Before getting started building an at-risk model, it is good practice to check your settings. For USACE users, because ACID will not let you automatically enable macros, you will need to disable multiple CPU support under the General tab if your spreadsheet has macros in it. This will obviously slow down the computation time, but will be the best you can do on a government computer unless you have an air-gapped machine that is off the network. On the Sampling tab, you can choose between Latin Hypercube and Monte Carlo. Latin Hypercube is preferred and is the default. It is also a good idea to disable the Smart Sensitivity Analysis under the Sampling tab. Smart Sensitivity Analysis pre-scans inputs based on their precedent and formulas for outputs. Inputs that have no link to an output cell are removed from the sensitivity analysis. This is nice, but the Smart Sensitivity Analysis can add significant runtime for large models, so it is often best to disable it. On the tool ribbon, there is an icon of a red die. When the red die is checked, at-risk will return on-screen random values within the limits of a distribution for each cell with an input distribution. The values will change every time the spreadsheet calculates. This feature can be very helpful when trying to see if the spreadsheet you are building is working correctly without running a full simulation by allowing you to step through some iterations. Just keep in mind that at-risk ignores any correlation matrices at this stage. Correlation matrices are only recognized when you run a simulation. When the die is not checked, at-risk will return the expected or mean value for the distribution unless you specify a specific static value. When working in a spreadsheet, especially one you are not familiar with, it is sometimes nice to know what cells have at-risk functions in them. You can do that by clicking the icon in the top right of the screen. By default, at-risk will shade the inputs blue, the outputs red, and the statistics functions green. You can change those default colors by going to Preferences and selecting Color Cells Preferences. Here are the basic steps to using at-risk. First, we are going to build a spreadsheet model. Next, we are going to define our input distributions, correlations, and outputs. Remember that at-risk will only store the simulation data for cells marked as an output. From there, choose the number of iterations. Then you are set to run the simulation and review the results. To add a distribution to a cell, click Distribution from the At-Risk tool ribbon and find the one you want. The At-Risk dialog box will step you through what you need to define the distribution. The other way to add a distribution to Excel, if you know the function, is to just type it in. When I covered the different probability distributions earlier, those were the functions shown in blue at the top of the slides. If you want to correlate distributions, you will need a correlation matrix. To add one, highlight all the cells with the distributions that you want to correlate. Click Correlation from the tool ribbon, and you should see the cells you highlighted listed in the dialog box that appears under Specify Inputs. Click OK, and you can start building the correlation matrix. The matrix will be a table of values from -1 to 1. A value of 0 assigns no association between a pair of variables. A positive number indicates a positive association. As the value of one variable increases, so does the value of the other. A value of 1 represents a perfect positive correlation. A negative number indicates a negative association. As the value of one variable increases, the value of the other decreases. A value of -1 represents a perfect negative correlation. The cells located diagonally across the middle of the table will always be 1 because a cell must be perfectly correlated with itself. If you change a value on one side of the diagonal, the value that mirrors it on the other side will also change. In the red box is the correlation between the distribution in cell C6 and the one in D6. The same two cells are represented on the other side of the diagonal, so both cells outlined in red will always have the same value, as will the ones in blue and green. Again, the table values can be anywhere from -1 to 1, but for our purposes, they will usually all be 1s because most frequently during risk calculations, we are correlating variables to ensure consistent percentile sampling. Once you have your correlation matrix filled out the way you want it, At Risk will ask you where you want to put the matrix inside the spreadsheet. You can pretty much put it wherever you want. Just be sure there's enough room for it because it will overwrite your work if you put it in the wrong place. You can move the table after you place it, so it is good practice to select a cell at the bottom of the sheet where there's plenty of room. You can also change the correlation values in Excel at any time. When you place the matrix, At Risk will create a named range and add some syntax to your formulas as shown. Be careful if you want to drag your formulas after setting up a correlation matrix. The number at the end is the distribution's position. It is a 4 for the fourth distribution, the cell highlighted in blue. This number would be a 1 for the distribution in column C, a 2 for the distribution in column D, and a 3 for the distribution in column E. Note that the number will not update if you drag formulas, so you will have to update them manually. At Risk will run all the input distributions you create, but will only store the data for later use from cells marked as outputs. Highlight the cell you want to mark as an output, then click Output and choose Define. At Risk will give you the option to name your distribution. You do not have to name each output cell, but it can be helpful later when reviewing the results. When you click OK, the output command will be added to the front of a formula, and At Risk will store the distribution of simulation results for that cell. After running a simulation, statistics can only be pulled from cells marked as outputs. You can define the number of iterations that will be run during a simulation from the tool ribbon. If you use Monte Carlo sampling, there are equations out there that will tell you how many iterations you need to achieve a certain level of confidence. But if you remember, At Risk defaults to Latin hypercube sampling. With the Latin hypercube sampling method, a smaller number of iterations will be sufficient to produce means within the desired confidence interval, but there's no simple calculation to predict the necessary number. Without getting too far into it, 10,000 iterations will usually be plenty. After running a simulation, which is done by clicking the Simulate button in the middle of the tool ribbon, you can browse tables and plots of the results. Click the small icon from the tool ribbon that has what looks like a caption bubble with a red bar graph inside. You can then click around to the different cells and see the results of the distributions you just ran. In the default view, you will see a plot of the PDF and the simulation statistics, but you can click on the plot options down at the bottom and can plot cumulative functions as well. Here is the CDF of the PDF we just saw. You can also call the statistics for an output cell using the functions provided in At Risk. To call the mean of a distribution, the function is riskMean, and the only input is the cell reference for the output cell for which you want the mean. You can call the value that corresponds to a specific percentile using risk percentile. The first input is the output cell reference, and the second input is the percentile you want it to return. This value needs to be in decimal form as shown, or input as a percentage. You can also call the value from a specific iteration using risk data. This is used when you want to make a scatter plot. The first input is the cell reference for the output cell. The second input is the iteration number you want to call, and the last input is the simulation number. Most of the time you will only be running one simulation, so the last input is typically a 1. You can also view all the at-risk simulation data in a single table. Click Explore in the tool ribbon, then choose Data under Simulation Details. If you click the footprint at the bottom of the table, the spreadsheet will update cells with the values from the selected iteration. It is a handy feature to understand the model when the results are not as expected, or when troubleshooting an issue. There are also options for sorting the data if you click the gear icon next to the footprint. When saving a spreadsheet, you will be asked about saving at-risk simulation results and graphs. By clicking Yes, you will save the data to the workbook. When files get large, it is best to click Options and save the data as an external file. Be sure to save the data file in the same folder as your spreadsheet. This way, the next time you open it and have @Risk running, @Risk will ask you if you want to load your simulation data. You can also save and open simulation files from the Utilities menu of the tool ribbon.